3, 2, 1, boom, and we are live. What's up, guys? Sorry for the delay. As soon as the contest finished, I just hit a run to the market because I needed some food and stuff like that. So yeah, you can't live without food, right? I think that's pretty pretty accurate. So what's up, guys? You're on Algopedia. It's your boy Andy. Welcome to another live stream. Welcome to another contest. We start as usual by showing me some love as I show you some love. If you're new to the channel and you have enjoyed the party, subscribe, like the live streams, and share with all your coder friends who join Codeforces, who like Codeforces and want to become better at competitive programming, right? So, okay, please confirm if you hear me well. I think this is a little bit too... Alright, I think now should be a little bit alright, because in the last live stream the sound was a little bit kind of too noisy, too loud, and yeah, I think there was a problem. So this being said, guys, I missed you, hope you missed me too. So we have had a very special event. Actually, today was a very special day because since like 2 or 3 years it was my first ever Div 1 Codeforces Round, right? So you can see my handle, which as you all know is Romeo Fantastic. Yeah, basically here I was like 3 years ago, and then now it was my first Div 1 round. So enough with the talking. They are judging right now. So yeah, this being said, basically these problems A and B from Div 1 that I managed to solve are Div 2, C and D. Alright, so I haven't solved A and B Div 2, but I've solved basically A, B Div 1 or C, D Div 2, and yeah, we are waiting to see if they're accepted or not. So yeah, not great, not terrible, but it's okay for my first Div 1 round. I kind of had a little bit of mixed feelings. So alright, you can hear me, cool. So what's up, guys? Let's start with C or A from Div 1, because I see a lot of spam in the chat and it seems like all of you want to solve this Johnny and contribution, right? So get ready, because we are solving Johnny and contribution right now. So Johnny wants to increase his contribution. Johnny is this magic Codeforces user, right? And as you know the statement, basically he wants to write n different topics or n different articles, and each article should have a topic, right? And basically there are going to be exactly n articles, and you have basically relations, right, between articles, which yada yada yada. You basically know the answer, the statement. Basically, let's get to the first input to be a little bit quicker. N is the number of articles and M is the number of relations between articles, right? A relation A and B means that they are related. Let's say it like this, right? So basically, what does he do? He chooses, basically he starts from 0 written articles and he chooses which is the first article, which is the second, the third, and so on and so forth. And when he chooses the article X, he looks at all his neighbors and he's gonna pick the minimum number which is not used by the neighbor articles, right? If this makes sense. So basically you are given this graph. Alright, let's cut to the chase. There's no articles and topics and stuff like that. It's a graph problem, right? That's obvious. So we are given a graph with n nodes and m edges, and we should pick a permutation I think, yeah, of n nodes. So a permutation of length n, right? And we have to pick this permutation in such a way that when we color the nodes, when we assign them numbers, like it is said in the statement, like following that rule, we have to end up with the configuration that we are given in the input, right? So it's simple, just to get the statement really clear. Now, what I kind of liked and didn't like, let's say, about this round was that the problem were a little bit too hard. I mean, I don't want to be that guy who says it was too hard because I didn't solve them, but I think the difference between Div 2 and Div 1 is very steep. Like in div 2, it's kind of easy to solve A, B, C, D. Easy if you, let's say, consider yourself a good coder. When you're in div 2, you're like, I solved A and didn't manage to solve B or something like that. So yeah, it's a big difference. But about this problem, there are 500,000 nodes and 500,000 edges. So obviously it should be something like greedy, sorting, constructive algorithm, stuff like that. So let's go through my process of thinking, right? I'm thinking about this problem and I'm like, all right, I have this graph and the nodes basically have colors or numbers, right? And how can I pick them in order to be able to do this? Well, let's put it like this. I have my Photoshop, create something new, untitled one. I think you can see the screen right now. Cool. So let's put it like this. Let's say I have somewhere a node which has the number 7. Cool. In order to be able, when I choose this node, to color it with 7 or to assign the number 7, all of its neighbors, right? There have to be at least 6 neighbors, which all of them have numbers 1, one of them 2, 3, this is 3, 4, 5, and 6, right? So this is my first idea, like, all right, I don't, let's say, care about the specific value in a node, but I know for sure that for that value to be assigned, I need all the neighbors to have assigned numbers from 1 to 6. Because if, let's say, 3 wasn't here, I couldn't assign 7. I would have had to assign 3, right? So at this point, I know one thing for sure. When I want to choose a node with value x, I have already chosen all the nodes with values from 1 to x minus 1. That's definitely for sure. After I thought about this, guess what? I take a look at the inputs and the outputs, like the examples, right? And I take a look at this one. 2, 5, 1, 3, 4. Are those nodes sorted by value? Yeah, they are, right? Node 2 is 1, node 5 is 1, and then all of them are 2. And first example is exactly the same. So when I noticed this, I was like, alright, so definitely a sort. First thing I do, I'm gonna sort the nodes. And if I sort the nodes by value, I basically know the permutation, right? I sort them, I know the permutation, that's it. Yeah, if it is possible. So after sorting the nodes, I still have to figure out if for some configuration or input example, it is possible to actually color or assign values to these nodes correctly, given the graph, right? So I still have to check that. Cool. So I'm like, all right, let's check that. How do I do that? Well, shouldn't be that hard, right? I mean, I have sorted the nodes increasingly. Cool. Then I can iterate through each and every node. Okay. And when, let's say, I want to check this node, which has value x, what should I do? What should I do if I have a node of value x? I have to make sure that among all its neighbors, I have each and every value between 1 and x minus 1. Okay? Can I do this by brute force? I mean, for each and every node, can I iterate through each and every neighbor and see what values are there? I think I can. And I will explain why. So I go through all the neighbors. Neighbor 1, neighbor 2, neighbor 3, and so on and so forth. And I see what values are there. Basically, I pick each and every value. And I store something like an unordered map, right? Unordered map. Or a frequency array, or however you want to call it. Just to see what are the values there. So I'm in the node. I iterate through the neighbors, right? After I'm finished, I know the values that are among the neighbors. And I just have to check if there are exactly x minus 1 different values which are less than or equal to x, right? So this is another thing. After I iterate through the neighbors and I basically mark the values as visited, as true, what I have to check in the end is that for this node to be assigned the value x, I have to take a look at his neighbors with values less or equal than him, right? So let's put it like this. For each neighbor, let's call it n. For each neighbor n, if the value of n is less or equal than x, right? If its value is less or equal than x, I don't know, something like frequency of that value equals true. And one more thing, I'm going to count how many different values are among its neighbors. And I'm going to do this using a variable. I'm going to have a counter equal to 0, and each time I visit a neighbor, I take a look at its value, and if the value is less or equal than x, before setting the frequency true, I check if the frequency is false. Because if that frequency is false, that means that this is the first time that I encounter that value. So I should increment the counter. And in the end, after completing this for loop, in the counter, I know how many different values less or equal than x are among the neighbors. If this counter is equal to exactly x minus 1, that means everything's fine. If not, everything's not fine. Because if I have exactly x minus 1 different values less or equal than x, right, I have to make sure, yeah, one more thing which is very good. I have to make sure that I don't have any neighbor which is equal to x. Did I check that during the contest? Did I check that during... Was it... Oh, alright, so it's accepted. Alright, cool. Wow. 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 I was a little bit frozen there. Because I, like... If I have some x here among the neighbors, this is not okay. So, we'll take a look at my source code and we'll see if it actually is accepted or not. So yeah, so basically that's it, right? For each and every node, I iterate through the neighbors, store them in a frequency array or in an order map, and check this counter. I count how many different are, and check to be exactly x minus 1. And why is this okay? Because it seems like a brute force, right? I take each and every node, and I take then each and every neighbor. Well, it's simple. If I take each and every node and each and every neighbor, what do I do here is that I take each and every edge twice, right? This could be common knowledge for you, but actually, if you imagine a graph with nodes and some edges, right? If I choose each and every node and iterate through each and every neighbor of this node, I basically iterate through each and every edge twice. So the total time complexity is something like n plus 2 crossed m, which is obviously big O of n plus m. So you're not gonna get time limit exceeded, it's not a brute force approach. You basically sort the nodes, and to check if they are valid, you brute force like this through each node and each neighbor. So yeah, I hope everything's clear. Yeah, I don't know what you want next, I can't see. Let's see quick the source code, because if you know the idea, the source code is not that hard. So basically, yeah, for each and every node between 1 and n, I just read its color x, color of I equals x, then I store an array of pairs, a of I is equal to the pair x and I, so the color, I call it color, and the node, then I sort it, obviously by colors, and after doing that, I take the node, which is the second number from this pair, and I count how many numbers are different, right, which is number different, and for each and every neighbor, if its color is less or equal than the color of node, I just increase the number of different numbers. And then I say that I mark basically in my frequency array that color to be true, because I don't want to count it twice, right? It's not going to be different anymore if I do that. And of course, if the number of different things is different than the color -1, I print -1. In the end, after I do that, of course, I have to make sure I reset this frequency array, because if I don't, I'm gonna go to another node and this frequency array is gonna stay the same, right? So also iterate the neighbors to reset the frequency, right? Don't reset the frequency by something like, what was that called? It was some function in C which kind of reset the values. Memset. Don't use memset or for loops of size 100,000 for that. Make sure you visit each and every neighbor again and mark it as false, right? Because only the neighbors were changed in the process, and that's gonna be fine, right? So yeah, that's it. And I think it shouldn't have been accepted if it was by me, because I don't know yet. You can correct me if I'm wrong. I don't know if this approach actually takes into account the possibility that I have a neighbor equal to X. So I don't really know if I take it into account. So it might happen that I have exactly color -1 different neighbors, but one of them is still color, and that's not correct. So yeah, I don't know. It is accepted, I'm happy with that, but I think it shouldn't have passed all the test cases. That's it. Sometimes you got lucky, right? So correct me if I'm wrong. Alright, cool. Cool. Problem C div 2, I just did it, man. This is A div 1, because I was in div 1, which is C div 2, so I did it. Yeah, okay. Div 1b, it's time for div 1b, which is also div 2d, right? So div 1b or div 2d, we can start. So, let's do this. Johnny and Grandmaster. So now, after wanted to be the best contributor of Codeforces, Johnny wants to be now a Grandmaster. So yeah, this problem was very tricky. I needed a lot of time to think about it. It was like, I don't know, man. I just think it was hard. Maybe I'm out of shape, but I think it was hard. So after you find the idea, it's like, come on, how haven't I thought about that? But it's not that simple. So if you know the statement, you basically are given some test cases, and for each and every test case, you are given basically n numbers and a number p, right? So you are given n and p, and on the second line all these k's, k1, k2, kn, right? So yeah, and the actual numbers are p at those powers. So you are given the powers, and each and every final number is p at that specific power. And what we have to do here is that, whoa, almost fell. What we have to do here is that we have to split these n powers into two disjoint sets, such that if I take the sum of those numbers from the first disjoint set and the sum from the numbers in the second disjoint set, right? These two sums have to be as close as possible. Their difference, their absolute difference, has to be as minimum as possible, right? So yeah, that was the problem. And obviously you are given 1 million numbers, and 1 million is p, and the powers are still 1 million, so everything's very great. 1 million, you can do dynamic programming, you can do anything else, but you have to come up with some legit solution. So yeah, that's what I did after all. Alright, so how have I thought about this? Let me just check. I'm curious if it... Alright, it's still in queue. I don't know what you say there. Div 1b is div 2e. No, bro, div 1... Yeah, so div 1b is... div 1b is div 2d. Alright, shout out to... Yeah, it's shout out time. Shout out to one of my ex-colleagues, which is Koca. What's up, man? I can't speak in Romanian. I would show you some love in Romanian, but I just can't. It's an international channel. Everyone's invited. So, salut, Koca. Stay cool. Stay awesome. Cool. Shout out time over. Let's get back to the problem. So, all right. Yeah. Cool. So basically, n integers, right? Good. This was the power, right? Good. And what I have here, this is the p. Alright, so have to split this into two disjoint sets. The difference have to be as close as possible. Let's see. First of all, I thought like, alright, cool. How should I approach this problem? Well, after I think 10 minutes of thinking about it or something like that, in which I had no idea, I was like, I really should think about some simpler problem, right? So I tried to make this problem as simple as possible, solve that, make it a little bit harder, solve that, make it a little bit harder, solve that, and so on and so forth. So yeah, again, I have proven one more time to myself that this works, and I really suggest to do that when you don't have a clue about how to solve this problem or any other problems. Make it simpler, man. Always make it simpler. Remove some constraints, think about the simplest test cases ever, stuff like that. That's what I did. So I basically have thought about the simplest test cases ever. And what were them? First thing that I thought about was, what if I have only one number, right? So I'm basically given some number. Yeah, I have p at power a1. What should I do? Of course, this number only goes to one set. Right, that's obvious. So this is the difference. Cool. What if I had two numbers, right? P at power a1 and p at power a2. What's gonna happen now? Well, obviously, I'm not stupid, so I'm not gonna take the both numbers in one disjoint set and the other one is going to be empty, right? That's not optimal at all. So what I'm gonna do is that this number in one set, this number in the other one, so the difference of them is going to be the final difference. Cool. What if I had three numbers? If I had three numbers, I think I can control Z. Alright, yeah, cool. If I had three numbers, P at power A1, A2, and A3, then this is still pretty simple. Yeah, this is still pretty simple because I think it's pretty obvious why you are not going to take three numbers into one set, first of all. So, yeah. You should take one number in one set and two numbers in the other one. But of course, you're not gonna take the smallest number in the first set and these two numbers in the other one, right? Because you're gonna maximize the difference each and every time. You're not gonna do that. You're gonna do something like, I can take the greatest number in one set and the other two, maybe, in the second one. That could be legit. Why not? And I think that's it. Yeah, I think this is the only option that you have. Do you have any other option? I don't think so. Maybe, let's say maybe, I'm not very sure about this, but maybe you take this one and these two, but I don't think it makes any sense, but okay, maybe, doesn't matter. So, I thought about this, right? Then, when I thought about four numbers, I'm like, alright, fourth number. What's gonna happen now? Well, this is kind of tricky. Because, first of all, I thought about I'm gonna take two numbers in one set and the other two in the other set. But that's not true. This number could be so big that you're gonna take him alone in a set. And these two are going to be the second set. Right? So this is when I started to worry. Okay, one number, two numbers, three numbers, really simple, right? But four numbers, I kind of started to worry because I didn't have a clue with four numbers. Because I can take this number alone and this three. Or maybe I can take first number, the smallest number, with the greatest one and this one in the middle. This could be a possible solution too, right? So yeah, I basically have a couple of options, and as I have more and more numbers, I'm going to have more and more options, and more options is not good because it's a larger time complexity. So I really have to make some observations here. I know for sure that in order to solve this problem, I have to make some observation that's gonna tell me, alright, there's no options here, you have to do that. And that's what I tried to do, and finally I could, and I did. So, what you see here, before we've talked about this, what you see here is that what worried me, right? Because I could have some example in which the greatest number is very large and the other ones are kind of smaller, right? I can have something like 2 at power 3. 2 at power 0, 2 at power 1, 2 at power 2. So in this example, definitely this is the greatest. And the sum of these other three is still less than this number, right? So this is definitely set 1 and this is definitely set 2. And this is going to minimize the difference, right? And then it started to click. I'm like, all right. So if I have a number which is so large that the other numbers, the other n-1 numbers, let's say, their sum is still less than that number, I think that's my solution, right? And yeah, it is. If this number is greater than the sum of the other ones, this is a set and the other numbers are another set. So I started to shed some light on my thinking. And I'm like, all right, when does this happen? This is obviously the case when p equals 2, right? So this is p equals 2. Let's think a little bit more general. When I have some p, right? So I don't know, I just have the greatest number ever, which let's say is p of a1, right? So let's say I take the array, for example, and I sort it decreasingly, right? So I can sort decreasingly the array, a1 greater or equal than a2, greater or equal than a3, dot dot dot, greater or equal than an, right? And let's take this number, p of a1. If this number is, let's say, very great, like p at power 100, and a2 is 99, for example, so I have p at power 99, a3 is 98, and it just gets smaller and smaller and smaller, this number is greater than the sum of all the other ones. But there is a possibility that this is not going to happen. And the possibility is when you have a couple of numbers which are equal. If a2 is 99 and a3 is 99 and a4 is 99 and so on and so forth. So basically you have this p at power 100 and you have, let's say, the next 100 numbers, they are 100 numbers which are equal to p at power 99, right? In this case, when p is less or equal than 100, this is not greater than this. Obviously, if p is 1000, yeah, this is definitely greater than that. But if p is something like 2, 3, 13, 20, something like that, these numbers actually trump the first one. So this is interesting. So the kind of the simpler scenario that I first thought about was that when this array a1 is strictly greater than a2, strictly greater than a3, strictly greater than dot dot dot, strictly greater than an. If all these numbers are unique, then I know for sure what is going to be the solution. Because if all these numbers are unique, so basically these powers don't have any coefficients, they are alone by themselves, alright, a1 is the first set, the other numbers are the second set, for sure. Because, as I've told you, this sum is less than p at power a1, so of course I'm gonna take the whole sum, I'm not gonna take something even less than that. So the only problem was that I could have equal numbers, right? This was the problem. What should I do with equal numbers? Yeah, first of all I thought about, if I have equal numbers, that's easy, right? Because let's take a2 for example. For a2 I have p at power a2, and if I have p such numbers, this is p at power a2 plus 1, so I can just convert them, right? I can just shift them into greater and greater powers. But that's not correct. That's definitely not correct. That is not correct at all, and I almost tricked myself with doing that. Because let's take, for example, I don't know, let's take, what should I take? Should I take 10? Yeah, yeah, or 2. I can take 2? Yeah, let's take 2. Alright, so let's say I have 2 at power 3, 2 at power 3, and I have 4 times 2 at power 2, right? If I convert this into a 2 at power 4, I basically have 2 at power 4 and 2 numbers equal to 2 at power 3. So the difference that I can obtain is 2 at power 3, right? So if I convert this input 2 at power 3, 2 at power 3, and 4 times 2 at power 2 into this one, the answers are not the same. The answer here is obviously 0, because I take 2 at power 3 with 2 of this, with 2 at power 3 in the second set and 2 of this, and the difference is 0. But with this input, the difference is always 2 at power 3, which is not okay, and this is okay. So don't do that. Don't shift those numbers into greater powers, because it's not correct. So after I thought about that for a long time, finally I got the solution, and I was very tired and like, alright, finally, let's just code this and get it over with. And yeah, that was it. So the final solution is that you will still sort the array decreasingly. So you will still have A1 greater or equal than A2, greater or equal than ... greater or equal than AN. After you do that, you basically have some powers, right? So what I did is that I have also found the coefficients, right? If A1 is equal to A2, I won't say p at power 100 two times, like this. I just said coefficient 2 crossed p at power 100, right? Just a trick to make things simpler, right? So I just checked if the numbers are equal and something like that, and I've end up with the final array, A1 strictly greater than A2, strictly greater than ... strictly greater than AN. But this time I have coefficients, right? So this A1 has coefficient C1, because this value of A1 in the initial array maybe was encountered 3 times or something like that, right? So basically, to cut to the chase, I remain with some polynomial, right? Which is coefficient 1 crossed p at power A1 plus coefficient 2 crossed p at power A2 crossed ... crossed coefficient n crossed p no, this is not cross, this is plus, sorry, plus, yeah, plus coefficient n crossed p at power an. This is the polynomial, right? And I should split these coefficients into my two sets. How do I do that? Well, again, think about the simplest problem, and that's what I did. I just ignored this. Let's say I just have one power. I just have C1 crossed p at power A1. That's what I do. What would I do? Well, it's a matter of C1, right? If C1 is even, that's very cool. Let's say it's 4. Alright, I take 2 crossed p at power A1, put it into the first set, and the other 2 into the second set. That's really easy. The problem is when this coefficient is odd. Because if I have an odd coefficient, unfortunately, one number is going to become greater than the other one. One sum is going to become greater than the other one. So basically this was the problem, right? I look at the first coefficient. Let's suppose it is odd. Let's suppose it is 3. Alright. Obviously I won't take all 3 into a set and nothing in the other. That's not smart at all, and you can prove it mathematically that you can't like optimize the difference after you do that. Like, it's game over if you do that. So basically, when the coefficient is odd, you're going to have something like k numbers in one set and k plus 1 in the other set, right? So just from this power, you will already have a difference of p at power A1. And that's a big problem, right? So, this was the problem, right? Take a look at the first coefficient. If it's odd, I'm gonna have this difference, p at power A1. And because I have sorted these numbers in decreasing order, this means that this difference is greater than any other difference that I'm gonna encounter, right? So, it is optimal to solve this difference. My first priority is to solve this difference. And how will I do that? Well, as we have seen, there are some inputs which are going to be something like C1 crossed p at power A1 plus when you have C2 crossed p at power A2, and this is odd, So you have a difference of p at power a1. What if c2 was exactly equal to p? If c2 was exactly equal to p, remember, we won't shift them into large powers, but we can. If it is necessary, we can. So if this is p, this is actually p at power a2 plus 1. And if, let's say, a1 was equal to a2 plus 1, I could have taken all these numbers, remove them from here, and increase the coefficient. And if I increase the coefficient by 1, this is now even. And if this is now even, the sums are going to be equal. And this was the final solution, right? Sort the array in decreasing order and just look at the coefficients. If the coefficient is even, Steven, come here, even Steven, right? That was the saying. Even Steven, that's cool. If it is odd, that's a problem. If I can solve the problem right now, I'm gonna do it. I don't care about afterwards. This is the greatest problem and I need to solve it. So I'm gonna take a look at the other coefficients and other powers and see if I can take a subset of powers from here and add them together in order to have obtained another p at power a1, so I can increment the c1 so it can become even, so I can solve the problem, right? So I think everything's clear for now. So yeah, cutting to the chase, after we sort it, and of course we know the coefficients by storing them into frequency array or something like that. If the coefficient is odd, I iterate through each and every position and try to add the numbers to obtain the bigger power, the larger power. If I can do that, that's awesome. I'm gonna do it, and then I'm gonna continue the algorithm for from where I've left off, basically. And if I can't do that, it's exactly the first example where I had p at power 10 and p at power 9, p at power 8, yada yada yada. So this is p at power 10, coefficient 1. This sum is strictly less than p at power 10, so I can't make this coefficient to be 2. So what I'll do is that I give up, I take this p10 into the first set, and all the numbers afterwards, I take them into the second set, right? So this is the solution, basically. Iterate through the coefficients, odd coefficients stop, take a look at the next coefficients with their powers, see if you can obtain the larger power. If you can, you increment the coefficient, everything's fine, and you continue. If you can't, you stop, you take the remaining number, because they are odd, into one set, and the other ones power which are less than that into the other set, and there's your difference, right? So yeah, basically that was the idea, guys. It's accepted for you. Alright, that's cool if it's accepted. Alright, nice, it's accepted, that's cool. Alright, so I see it's pretty dark in here, so you probably don't see myself very well, but that's not a problem because anyways we are finished with this. Let's take a look quick at the code, and if we understand the code, then everything's fine and we can move on. So yeah, the code is a little bit hard, but you're gonna have the links, the link to my source code. Let me just open the light because I don't see. I think you can see me now. Right, cool. Hopefully you see me better, right? So yeah, I don't know if my father texted me that. Oh, he didn't. He missed this one. Yeah, what can I do? So yeah, alright. So, alright, just a quick look at the code. I hope you understood the idea. So what I did is that I just read the array of powers, have the frequency array, so count each power how many times it occurs, and these are the coefficients, right? Cool. Sort the array and reverse it, so sort it decreasingly basically. And then I just take care of the duplicates, right? So if I have duplicates, just remove them because I have now the coefficients, so I don't want the duplicates anymore. And after I remove the duplicates, I start from position 1, have a while loop. If the frequency of A of pos so the coefficient is even, continue. This power is fine, I can split it equally. If not, that's a problem. So what I do is that I take x, which is the power, and counter need, which is 1. This tells me that I need exactly counter need numbers that are equal to p at power x in order to make the coefficient even. So I start with counter need 1 x at power pos, and I just move with a for loop through the next powers. And I see, when I am at I, I'm gonna need. So yeah, you basically have to do the math for this, but not that hard. So if I needed counter need numbers equal to p at power x, this means that when I should convert them to p at power a of I, right, which is my current power, I'm gonna need counter need crossed p at power x minus a of I, right? So let's say if I needed 3 numbers which are p at power 10, I'm gonna need 3 crossed p numbers which are p at power 9, right? And so on and so forth. So that's the logic. So I have a function to compute this because this could be actually very, very large. So I have to make sure that I compute it so I don't overflow, right? And then I see if new counter need, so how many of these I need now, is -1. -1 means that I have overflow, so there are a lot of numbers, I could never reach that number. I just break because I know I can do it. So is good is 0. If it's less or equal than the frequency, everything's fine. I needed 7 numbers and I have 10. I can take 7 numbers from here and take with all the numbers and add them together to have a greater power. So if this happens, is good is 1. Position is I because I stopped here, right? So if I started in position and I took all these numbers, then the position is going to continue from here, right? Because these are 0. Cool? Position equals I, of course, remove those numbers from my frequency because I now use them, take them together with other ones. And else, if I can't do that, let's say I need 10 numbers and he can only give me 7. Alright, I'm gonna take the 7 numbers and I remember the following thing. I needed 10 numbers equal to p at power x. Now I need 10 minus 7 numbers equal to p at power, what's this power, right? A of I. So in the end, after this for loop terminates, if it's not good, so I didn't manage to solve this problem, I didn't manage to increment the coefficient such that now it is even, this means that I stop, just as I showed you. And if I stop, the difference is going to be p at power a pos, right? So this number, which is the greatest, p at power 10, and in the second set, each and every next number, which has a power less than it. So the difference starts as p at power a pos. Of course, I do logarithmic power, because a of power pos is, I think it's okay to, no, not okay to do it, because this could be 1 million, and you have something like 100,000 tests, and if you hit that 1,100,000 times, then time complexity is very large. So make sure you do the logarithmic power. And I take each and every number, and yeah, as I told you, I take coefficient, cross that power, and because this number is now in the second set, this number with its coefficient should be decreased from the final difference, right? So start off with p at power a pos, decrease these things, and basically count the difference. Again, as in the previous problem, make sure you reset this frequency, so the coefficients, because each and every time you're gonna need, for each and every test case, you're gonna need to recompute the coefficients, right? So yeah, basically that was it. Take the array, sort it decreasingly, remove the duplicates, take the coefficients into the frequency array, and then when you find the first coefficient odd, try to solve it. If you can solve it, that's cool, the difference is still 0, and continue from where you should continue. If you can't solve it, stop, compute the difference, and print it. And that was it. As you can see, it's accepted, everything's fine. I don't know what's going to be my rating after this. I don't know what place I am. Alright, I am 480. Not great, not terrible. Let's say I'm gonna be 500 or whatever it's going to be. So yeah, it's okay for my first Div 1 round. And that's it, right? So, this was it, guys. I love you all. Thanks for joining the live chat. Thanks for joining the stream. Thanks for the support. And please, as you know, I'm a very enthusiastic guy about competitive programming. I try to be the best teacher that I can, but in this period where I'm very, very busy, I need a lot of your support. Lot of your support. It helps me morally and with the time. So please, always, and never forget to subscribe. If you're new to the channel, subscribe, like these live streams, and share it, man. Share it with your friends. Share it with every coder that needs to see this and needs to solve this awesome problem with us. Because as you can see, I try to explain each and every millimeter of the idea as good as I can. So yeah, I hope you appreciate it, and I hope you are going to continue solving the problems, being here on Algopedia, subscribing to the channel, and stay awesome. Andy out. Have a nice one.